So, good evening, everyone. Welcome to the September 10th, 2010 meeting of the Royal Astronomical Society, Ottawa Centre. Are there any non-members, visitors in the group tonight? Anyone here? Raise hands. Oh, plenty of them. Okay, welcome to the meeting. I'd like to point out, as we usually do, that there's no requirement for you to be a member to attend the meetings. You're quite welcome to come along. A little later in the meeting, we will talk a little bit about the benefits of membership. So, those of you who were kind of waffling about why would I or why would I not become a member of the society will at least have an idea of what you're looking at. I have to admit myself, I attended meetings for quite some years before I became a member. So, don't be shy. You don't need to. Everyone is welcome here. So we're going to get underway right away. Do I see Al Scott in the back there? He's there. Oh, Al is here. Okay. So we're going to do some fancy footwork here. Are you all ready to go, Al? Sure. Okay. So we're going to get underway, starting off with the astronomy news. We'll follow that with Alain, or actually Carmen, speaking to us about the FAAQ conference that's about to happen on the other side of the river. Mike Mogadam, as usual, will speak to us about our public outreach efforts and the wonderful job he's been doing there. We'll take our break, and then we have some awards for members. We have some observations. We have our lunar, solar, and deep sky challenges, and a few announcements at the end. So no heavy-duty talks tonight. It's mostly observations and talking about getting out and looking at the sky. So without further ado, I'll welcome Al Scott to talk to us about the 10-minute astronomy news update. Thank you. Oh, the light. Oh, yes.
Thank you. Good evening. Welcome. Thanks for coming, everybody. So right up front and center, Bill lied a little bit about no heavy-duty talks. I have an equation. I must apologize, but this is some really interesting breaking news. So I thought I'd get you when you're all fresh and you're not tired yet. So astronomy has long provided a laboratory for physics experiments, astrophysics with its huge energies that you can achieve in the center of stars, uncomparable to anything that we can get here on Earth. Empty vacuum, huge distances, the size. The element helium, for example, was originally discovered not on Earth, but by looking at lines in the emission from the sun. Other things, in the past decade, we have come to really understand our place in the history of the universe, and it's due to this study of ancient supernovae, and it's the cosmology that we derive from these measurements that help us here. As well, the laboratory of the stars and nearby galaxies has shown us that the laws of physics, as we measure them here on Earth, appear to be fixed in the nearby universe. And when I mean nearby, I mean in the millions of light years. So it's not nearby as in the neighborhood grocers, for example. The emission spectra that we can measure from galaxies, from stars and galaxies, give you a fingerprint of the resonances of the atoms that make up the stars that are emitting this light. And what this tells us is that the electrons and the nuclei in these atoms basically behave the same in a galaxy millions of light years away as they do here on Earth. And this tells us that the laws of physics are relatively constant from here out a million light years away. And they've been constant over the last million years to as precise a measurement as we can make. Well, this observation deals with a law of physics and a number called alpha, which physicists call the fine structure constant. It's a ratio governing interactions of electrons and photons, basically things that create light, things that we can measure across the galaxy. If alpha were to vary, the energy of the electromagnetic resonances in atoms and molecules would change. Things would be different color than we recognize them. Chemistry would be different. A measly 4% change in alpha would be enough to make the universe completely uninhabitable. to life as we know it. Nuclear fusion just wouldn't happen. The value of alpha is related to a lot of interesting letters here, Greek letters, but these all have important information. Charge on the electron, the permittivity of free space, Planck's constant, which is associated with quantum mechanics, the speed of light. By measuring alpha in the nearby universe, we know that these things have all been very constant over the last 100 million years or so, even a billion years, and out to billions of light years away. Well, what these people have done is they have measured the fine structure constant from quasars in the distant universe. The accepted standard model of physics doesn't provide any guidance on what this number should be, nor is there any mechanism for change over time. Richard Feynman, the famous physicist, once said, "It's one of the greatest damn mysteries of physics, a magic number that comes to us with no understanding by man." Max Born, intimately involved in quantum mechanics, said of this number, "It is clear that the explanation of this number must be the central problem of natural philosophy." On September 7th, Australian astronomers announced the most precise measurements yet of these distant quasars, measuring absorption lines from gas near the quasars, billions of light years away, 10 billion plus light years away, near the edge of the universe. These are the most precise and accurate measurements yet, with astonishing implications. Radiation from these objects has traveled for billions of years before reaching Earth, and will have passed through these ancient gas clouds, providing these fingerprint absorption lines. Because of the specific wavelengths that this light is absorbed, it tells us of the resonances of the atoms in these gas clouds billions of light years away. And what we see is a systematic shift in the spacings between these lines, not an offset. We see offsets, they're redshifts. We know that these galaxies in the distant galaxy and in the distant universe are moving away from us. But what we instead see is a change in spacing between these lines, a spreading out or a contracting. And that's related to the fine structure constant, which is taken by the standard model to be fixed. These authors published their initial results based on Keck telescope measurements back in 1999. Highly controversial. People didn't believe it. They said the light from the north, there's a slight shift. It's something like 5 parts in a million. So, less than a thousandth of 1% change. And people said, well, it's just an error in the measurement. There's something wrong with the telescope. Maybe there's something wrong with your apparatus. Well, what they've done over the years is they've responded to these concerns. This is how science works. They publish a controversial measurement. Now, because it's such a staggering implication, they have to do a lot of work to back up this data. So the debate has been raging. They recently took to the VLT in the southern hemisphere and measured again. Let's try wholly different equipment to see if this happens. And what they found was it was completely different, the measurement they got. They said, oh no, our measurement doesn't work. There's something wrong. But then they thought a little bit more about it. In the northern hemisphere, it was a negative shift. In the southern hemisphere, it was a positive shift. So they thought, must be a systematic error in the equipment. But then they looked closer at the numbers, and they found out that actually there's a smooth variation from quasars at the South Pole to quasars closer to the equator, and then up into the north. And that is interesting, because in the survey of quasars that they did, they measured some of the same quasars on the equator with both scopes, and the results were the same. So what this means, or what this suggests anyways, is that the fine structure constant was larger by 1 part in 100,000 in the southern direction about 10 billion years ago, and smaller by a similar fraction in the northern dimension billions of years ago. And we have a smooth gradient over the sky. So that's really an interesting result, because it means that the laws of physics may not be fixed over the universe. The changes we're looking at here are very small. The results obtained suggest that there's any time variation. It may be less than the variation within position in the universe. So if correct, new physics is going to be required to explain something like this. The implications of these results are so resounding that they're likely to cause continued controversy in the scientific community. Maybe there's some geometrical effect in the solar system which is causing the measurements to differ in different directions. It's not a settled issue by any means, but it certainly is interesting. There's a clear asymmetry in the measurements between the north and the south. What could cause it? Certain laws of physics, for example, grand unified theories do suggest that the value of alpha will change over the universe. So what this may be doing is determining which laws of the universe are appropriate and may help us to move on beyond the standard model into more of a grand unified theory of physics. So, now that I've put you all to sleep, we're going to move on to something a little bit lighter, as Bill suggested. There's a movie I've downloaded from the web, which is 30 Years of Asteroid Discoveries. Can you play that, Chris? Sure. These are data compiled by the Minor Planet Center, and it shows, you can barely make out the date down here, but it starts in 1980. And you can see the white dots are all the discoveries as the Earth moves around in its orbit. So we got Mercury, Venus, Earth. So you can see people are looking out from Earth on the dark side and discovering new asteroids. There's Mars. And this is the tally here. It's kind of hard to make out of known asteroids. You'll see brief flashes of white corresponding to various deep astronomical surveys, searches for the moons of the other planets. Here's Jupiter. So every now and then when the Earth passes close to Jupiter, you'll see a bright white streak of discoveries. This is not for the claustrophobic either, because the number or rate of discovery really does increase as we get into this century. At some point late in the simulation, you'll see lines appearing at right angles from the Earth due to the WISE spacecraft, which is in orbit now. You can also see these are accurate orbits for the planets. You'll see close approaches between the Earth and Mars coming up every 2 years. The green asteroids are the asteroid belt. You'll also see some red ones, which are Earth crossers. They're starting to build up now.
Really thick.
Oh yeah. Well, space is big though, and these are very small dots. These dots aren't to scale. It's really mostly open space here, but you can't make the pixels small enough.
Otherwise you couldn't see Jupiter.
And you can see now we're getting some discoveries out beyond here now in some of these deep surveys. We're really speeding up here. In 2003, there's an interesting close approach between Earth and Mars, which is actually the closest approach between Earth and Mars in living history. And I'm going to reference that at my next slide. Now you can see we're really starting to accelerate. You're getting dizzy? Now you can see really on the outer branches. Now the WISE spacecraft now is making discoveries. So there you go. It's kind of a neat video that gives you a feeling for just how much we've discovered. And you know, it was going in the hundreds at first, then it was going in the thousands, then it was going in the tens of thousands, you know, per month. It's quite interesting.
What's the tally right now? Do you know?
I think it was close to 100 and some thousand, 130,000. And this leads me to my last slide. Again, going from heavy to light.
To science.
Who here has received this email? Put up your hands.
How many times?
Yes. This email is a really good example of an email hoax. It's not really a hoax, it's really a virus. It was an informational email that mutated. The original closest approach of Mars was in 2003, August. And someone put out a great description of how if you look at 75 times magnification, Mars will appear the same size as the full moon to the naked eye. Well, the email mutated and the 75 times magnification disappeared in a game of internet telephone, making it really an interesting email, but not quite realistic if you realize that Mars and the moon are on relatively circular orbits and are never really going to get close enough for that to happen. So a relatively benign informational email mutated through this huge game of telephone, probably not intentionally, mainly just ignorance and carelessness. But then it lost the date, and that's when it metastasized. Now, this email will never die unless we can inoculate the public with sufficient intelligence to kill this virus.
I think one of the early problems with this was that at the time, Mars was supposed to have a diameter of something like close to 30 arc seconds. Maybe Rolf, do you remember what that was? I think it was 30 arc seconds.
25.4.
Right.
Rolf doesn't need inoculation.
But the moon, of course, is 30 arc minutes in diameter. And I think it was an honest error. People were thinking, well, 25, 30, they're about the same diameter, except that the units were wrong.
Okay, well, maybe. But interesting nevertheless, I've received this email every year since 2003, and every year someone says, is this true? And it's like, no. In fact, I think I've got it from my mother twice. Oh, well. So we went from heavy to light, and now I'll pass on to the next. Thank you.
Thank you, Al. Okay, next up to speak to you about an upcoming conference that's happening in Quebec, just across the border, is Carmen and Alain. Thank you.
Mine is not even light. It's a no-brainer because it's about a conference. If you could go to the next. I'm Carmen Nadeau, as he mentioned, and I have my husband hiding behind me, Alain Denré. And we're members of the Regroupement des Astronomes Amateurs de l'Outaouais Québécois, which is quite a mouthful. We're about now reaching almost 50 members that share the passion of astronomy, just like you do. And we meet every second Monday of the month, and we have all sorts of observation activities and public presentations, similar to what you do, and especially a 2-week-long astronomical camping at Lac Éco, which we just completed a couple of weeks ago.
Okay. The Fédération des Astronomes Amateurs du Québec, better known as LAFAC, it's a federation that has a mandate to support and provide services to local organizations such as ours. And on a yearly basis, it organizes or it sponsors a conference. And for the very first time, next please, for the very first time this year, it will be in the Outaouais at the Hotel Holiday Inn.
So it's September 24th, 26th. We'll come back with the details later. Usually there's about 100 to 200 amateur astronomers that gather together, people that just love to look at the sky, astronomy lovers from across the province. And we have conferences mostly from amateurs, but also conferences from professionals that come Saturday night in particular and Sunday morning at brunch. We have kiosks and we have displays. And this year, we're the club that supports the organization of the convention. So this is the organizing committee. So a bunch of people just like yourself that just love astronomy. Next. So the basic information for the convention is that it's going to be at the Holiday Inn in Hall the weekend of September 26, 27, so not next weekend, the weekend after. astronomy in the Outaouais, universes to discover or to be discovered is the theme that we've chosen. In the province of Quebec, the Outaouais is sort of a unknown area. They don't come and visit us that often. So we sort of played the theme that come and visit the Outaouais and come also visit and discover the Outaouais and also discover the universe at the same time with us. Discover a bit what we do and through the talks that we'll have, learn other things about the universe. This is the website. We have pamphlets that we'll leave for you to pick up. Next, please. What I need to mention is that this is in Quebec and it's a French conference. The conferences are in French. So this is the program that we will have. So there's 2 segments running in parallel. And if we're lucky and weather permits, we'll have someone outside that has hooked up sort of a CRT or a TV, and he'll look at the sun. He'll be there and do some public observation if weather permits. So things like women in astronomy, mirrors, universes to discover visually, astrophotography. So various topics from amateurs. Now, at night, we have Alain Bernstein, Mars, Discovering Mars, apparently very good from the Space Agency, and Pierre Tourné and Daniel Girard the next day, introduction to, from amateurs, again, introduction to René Doyon, James Webb's telescope, who's going to be also our another professional is going to come and talk. I should mention also at 11 o'clock, Antoine Bouchard from the McGill University. Recently in the Sky, there was an article by on pulsars by, what's her name again? A lady that works there, and he's part of her team. They discovered a couple of years ago the fastest turning pulsar. So promising conference. Next, please. So what I would like to do tonight is invite you to join us in discovering together all these beautiful the topics of the astronomy. Next. So I have deals for you. The $15 deal is the 3 public conferences can visit our kiosks and displays. That's free. That's going to be open to the public. But $5 each, so you don't have to attend the 3 of them. You can select and choose. So you can attend for $15 or $5 each any one of these public conferences. If you really want to come and be hooked, next please. For $6 more, you can come and join us. We're doing a big deal. We're going to go a big gang together and go see Hubble 3D at the group rate. And we'll extend to you the reduction. So the group rate would not, the regular price is usually $12. The group rate would be $9. So we're going to pay $3 out of your ticket if you come and see Hubble. It's going to be in French. It's at 4 o'clock on a Saturday. Next, if you want the whole shebang, then for the price of $60, we're extending the price that we offer the FAQ members to attend the entire conference. And you get a dozen and more, as you can see, the conferences that you can select from. More than that, if you want to really dig into it, if you wish, you can join us for this. We have a banquet Saturday night, $50 for that. We have a Sunday brunch in the morning, $20 for that. And you get a chance to meet other fellow astronomers. So to register, you can come and see us at break, or you can email us. You can email us. The email is on, the information is on at the website, or It's in the pamphlet, so you can go through the address of the website is on the pamphlet, so you can reach us through there. Any questions? So hopefully we'll see some of you join us.
Come in.
Yes?
How long have you been involved in astronomy?
More intensively, about 6 years. On and off, more than that, 15 years. We used to come here.
Oh, did you? Okay.
Way back when Mr. McCumshan was doing his little piece on astronomy.
Yeah, the cutting edge news.
The cutting,
I think it was at
exactly.
the time, right? That's fine.
Yeah.
While you still had hair, Brad.
Actually, I remember you. I don't remember your name, but I do remember you were there.
Brian McCullough. I was
Yes.
I was talking with Alain by email during some of the
That's right.
Senate for this.
That's right.
Okay. Merci, Clement. Okay, next up, if he's here, Mike Mogadam has got a report on our outreach activities. Are you here?
Well, hi everyone. Just a few an update on what's ahead for our outreach. First big event, of course, is that's coming up. In fact, tomorrow is our star party, one of a series of star parties that we have had in spring, summer, and fall. Just click again, Brian, or Chris. For those of you who aren't familiar with our star party, these are public stargazing sessions. Our members bring their telescopes set up for the public to look at the stars and planets through. It's free. We have a lot of fun. It's just a terrific time. Our chosen location, the location we have picked, is the parking lot of the CARP Public Library, CARP branch of the Ottawa Public Library. It's right beside the Diefenbunker, so it's a pretty a well-known location. And you can see in the bottom there, it's actually in the bottom left corner there where the parking lot is. So lots of fun. And I hope you can make it. Keep your eye on our website, the ottawa.rase website. I'll make the go, no-go decision probably around noon tomorrow. Keep my fingers crossed that the weather won't change on us. Okay?
That's a typo, Mike? September 10th, so it should be the 11th.
I'm sorry, you're right. Thank you. That is a typo. Thanks for pointing that out. So it is, yeah.
No typos.
So Eric, what were you talking about, Eric? Okay, the next event after that is October the 9th, and I'll announce that when it comes. Okay, next slide, please. Okay, I get from time to time a number of outreach requests. Here's one that came from a community center near Ashbury College, the Lyndon Leah Community Center, and they've asked for a presentation and stargazing support. So I am looking for a volunteer who can deliver a presentation and also give a telescope. I have one volunteer already, but I'm looking for two. So if this is of interest to you, if perhaps if it's in your neighborhood and want to give it a try, contact me, please. I also do have some canned presentations. If you don't have a presentation, I'm happy to share with you some presentations that I've sort of gathered over the years. All right, next slide. Okay, this is the really big event. Okay, this is you may remember a year ago, we were approached by the group that's organizing an event called Science Fun Fest. This is one of a series. It's actually the flagship event of the National Science and Technology Week. Really, this is an event that is geared towards families and youth and so forth, just to develop interest in science at an early young age. Last year there were, oh my goodness, 56, I see there, 56 exhibits, lots of hands-on. So there's various groups mainly from the government, also from local organizations such as ours, set up booths. It's very sciencey, lots of hands-on stuff, lots of interactive stuff, lots of giveaways, and tremendous amount of fun. What blew me away was just a couple of things. The organization was extremely well organized, the entire event. And there was just so many different groups with many, many different volunteers. So I've got on the stage here a series of posters and on the one side is English, on the other side is French. If you'd like to take some of these and maybe post them at your workplace, please feel free to do. Take as many as you want. This is a free event. It's not. We are planning on attending the Ottawa RAC. Next slide, please. And like last year, we had two separate areas that we set up in. We had an indoor event where we had lots of our typical astrophoto displays and lots of giveaways and indoor telescope setup and impact crater display and meteorite displays and so forth. And we also had an outdoor event. The weather was just terrific. The skies were clear, and it was solar observing. And we had just a huge turnout of folks with telescopes. Last year we had 18 volunteers. I'd like to have at least that number this year, because really the sky's the limit here. It was just a monster event. They estimated the overall organized estimated about between 5,000 and 5,500 people attended. We had a good number of those that actually went through our exhibits. So the more people we get to help organize this, the better. I also am looking for help to plan this and just sort of go through the logistics of this. So if this is something that you want to get involved in and want to sort of wet your feet and get involved in this kind of thing, let me know. I could sure use the help. All right, but it's a tremendous amount of fun. The National Science and Technology Week organizers treat us very well. They give us whatever equipment we need. Tents, generators, you name it, the whole thing. And they also give us lunch and shirts and so forth. So they're extremely easy to deal with, and they really take away a lot of the work. They do a lot of the work for us, including a lot of the promotion. Okay, so I'll be talking about that again, and you'll be hearing about that in emails and so forth. It's a big event. Okay, next slide. Okay, another group that approached us is another seniors home here, and the same story. They're looking for a presentation and a stargazing as well. So I am looking for one more volunteer for this, and this event is near CHEO, the Children's Hospital there. So if this is something that interests you, if you want to give it a try, it's usually a lot of fun. We get we'll get typically some very good questions and very tough questions sometimes for these things, but it's anyhow, it's just nice to try. Looking a little bit further ahead is the annual winter solstice, where we support the museum with their celebration of the winter solstice. That's, of course, Tuesday, December the 21st, and it's and really what we have done in past years is just set up our telescopes, typically outside, and that's about it. Okay. Next slide, please. One thing I wanted to share with you, I get a whole range of outreach requests. Okay, and we got one about a month, more than that, just a couple of months ago, from a guide at the National Gallery of Canada, who I guess she did a lot of she tours of paintings and so forth, and she said she said that she had a painting by this fellow here on the bottom right there, a gibbous moon, and really what she wanted to do is she wanted to sort of liven up her presentations, her talks, and wanted to have some information on maybe some the myths and lore associated with the gibbous moon. So I put out a note and enter Brian McCullough, and Brian is working with this lady, and from what I heard, Brian, it's going well. You had a pretty good discussion here. Brian, doesn't that look like something that you created on this stage about a month or two ago?
Just about. What's interesting in that is that this artist Patterson Ewan,
okay,
he and I share a birthday, April 7th, a few years apart, and he's dead.
All right. I think that's it. I hope you can join us in the events, and hopefully keep our fingers crossed that tomorrow the weather will hold and it'll be clear skies. Thanks, everyone.
Thank you. Many thanks to Mike. Lots of interesting outreach activities going on in the next little while. Next up, Al Scott, who presented our astronomy news update just a little earlier, has brought down another 10 of the Galileo scopes. For those of you who aren't familiar with these, they're a telescope that duplicates the optics of Galileo's scope that he used for his early discoveries, but it's been produced in a modern way. I believe the main tube is ABS, for example. It's got some good quality glass in it, but of course it's limited in size. Wonderful thing produced to celebrate the International Year of Astronomy last year. The center still has a few of these. They're available to anyone who wants them. They're $35 a piece. So if you are interested, look for Al during the break, and I'm sure he can hook you up with one of these. So next up now, we've got Chuck O'Dale to bring you a trivia question. Chuck.
Thanks, Bill. Okay, first the rules. No fair Googling. Essentially, I'm going to give you the question, the who, what, when, where, why answers is what I'm expecting. A minimum of 3 of those to get the prize. The prize will be, I have a movie of the Apollo 13 almost disaster in the very high-tech format of VHS. So the winner will get to bring that home. And the question, okay. So one day I was out looking for meteorites and meteorite craters, and I looked up and I saw this. I said, what the heck is that? Now, that object is within 20 kilometers of where you're sitting right now. The question is, who, what, when, where, why?
Is that where Princess Diana is buried?
Close, Brian. Boy, you're close. So I will be here during the break. The best answer gets the movie. A minimum of 3 of the questions. So take a good look, and I'll talk to you on the break.
So next up after that will be Chuck with the answer to tonight's trivia question.
Okay, first off, if anybody wants a free tape of the Apollo 13, you can see me after the... Okay, I'm not surprised that nobody knew about it because I researched this thing for a long time to figure out what it was. So there it is, and just zoom out and see where it is. Dun, 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 dun. Now, I'm sure everybody at the been through the terminal have seen this. And the question is, what is it? Well, I'll let you just go ahead. So there it is from just off of the end of 07 with a 319 going by it. So that's a giveaway right there. So it's at the airport. What is it? Well, not quite. It looks like it. It's got an observatory. It is an observatory, and it was designed for a theodolite. Now, as I say, I'm not surprised nobody knew about it because I asked just about every older person that's still working at the airport, and nobody knew about it. One of my contracts is I actually escort contractors onto the surface of the airport across active runways and so on. And I can listen to the tower. And I'd say about 3 times a day, one of the pilots say, what is that white observatory up on top of that hill? And the controllers don't know. But if you look at it, that is a beautiful dome up there. It is an observatory. Zoom in one more. And it's still functional. It's sitting there. It's been sitting there since about the 1950s. The hill that it's on was built 1 scoop at a time from a pit right behind it. And the purpose of that building was for testing electronic gadgets in the 50s. So essentially, it was a sort of there's metal on it now, but there was a pure wooden building. So there was no EMF, electronic interference or anything like that for it. They could test their electronic instruments. And the theodolite was before the days of GPS and accurate LORAN. The theodolite was to get a precise position for these electronic gadgets. And just zoom in one more, please. So this is the inside of the dome, still in pristine condition. That, where the plug is, that's actually the plinth where the theodolite was going to be installed. And this is a typical government project. They built the hill, they built the building, they put the dome on top, they built that plinth as solid as a rock, and they ran out of money and they stopped the project. So since the 1950s, that thing has been there ever since. Now, I tell you, as I mentioned, I'm a contractor at the airport, so I have access to just about anywhere. So, of course, I just go up there and see what the building is. So that's the airport from the top of that hill. And the windows now are all blasted out from the weather and so on, so I climbed in to get those other pictures. But last summer I climbed in there and the heat was still on. So I told the airport authority about it, and they finally disconnected the heat to it. So that's the story. If any pilot asked you, now you know more than all the Air Canada pilots going by there, and the controllers, so you can tell the controllers. But that dome is in pristine condition, and I'm sure some amateur somewhere would love to have it. To get it off there, of course, is going to be a project. That building, as you see, is almost ready to go, so it's going to collapse on its own weight very, very shortly, unfortunately. But that plinth is as solid as a rock. I kicked it and I hurt my foot. That's how solid it is. Setting up an observatory there, well, of course, at nighttime you're getting very bright lights and these big aluminum things landing, so you're not going to get very much observatory done there. But there you go. So the next time you're in the terminal, look to the southwest-ish for this dome, a little white thing on top, and that's what it's all about, a theodolite. And if anybody wants that VHS tape, please see me after the show.
All right, thank you, Chuck. A little bit of trivia. You're probably the only people in Ottawa who know about that. So we've seen this slide before. We like occasionally to mention to people who are non-members, and maybe to people who are members as well, some of the benefits of being members of the society. It's rather a long list. I'm not going to go through the whole list. You can relax. That's not the point. This is more just to lead us into the next topic. One of the benefits as we go down through here are the observing certificates that are offered by the Society nationally. There are a number of different observing certificates available, and these are well, in some cases, these are the crests or logos for the various certificates. So I've got a few notes here. Bear with me a moment. We've recently been contacted by the Society regarding the issuance of pins for some people who already hold certain of the certificates. The Society has decided to also award pins when one completes these. But I thought before we got into the awarding of those, I would give you a little bit of information, because when I was browsing the national website, looking at the information about these programs, I realized there's very few Ottawa names on any of the lists here. They're kind of interesting programs, and I'd like to encourage members to go out and get some of these. So just to give you an idea, the sort of introductory one is the Explore the Universe program. It's on the upper left there. What is it? The forms are available. This is a program of basically 110 different constellations, the moon, solar system objects, deep sky objects, double stars, that sort of thing. To receive the certificate, you need to observe and document observing 55 out of the 110, which is not a heck of a lot. Surprisingly, there's very, very few names on the list from here who have achieved this. I would think just about any member interested in observing would find this very easy to do in a matter of a couple of months of observing time, even with the dismal weather that we have around here. So I'd certainly encourage you to go take a look at that. Now, beyond there's the Messier program. This encourages you to observe the 110 Messier objects, or 109, there's some debate about one of them. But nevertheless, there's a list of 110 objects to be observed, and they provide the observing note forms for you to make your observations on. I took the liberty today in the office, don't anybody tell my employer, and I printed some of these out. So this, for example, is the set of forms for the Explore the Universe certificate. It's a nice, compact little set of pages. It gives you a lot of directions. It's a helpful little set of observing notes, and it's also got all the places for you to record the various observations you've made. When you're done, you just scan this, send it in to the national office, and in short order, your certificate comes, and you're honored in front of all your peers here. Wonderful. Messier, similar, but a little bulkier. But you can see, again, there's nice observing pages provided, information about the object, and a place for you to make your sketches and write down any observations you have. Same goes for the Isabel Williamson Lunar Observing Forms. Interestingly enough, I don't see anybody from this center who holds the Isabel Williamson Lunar Observing Award, including the infamous Brian.
Does it count that I've already printed off all the pages for that? So I thought I'll go back through my years of presentations and sketches where I've already made the observations, and then see what little holes might be left, and I'll do it.
Sure, Brian.
Oh yeah.
Yeah, sure. Okay.
No, but that's the thing, because as you say, these are very good programs to do, and you can learn a certain aspect of the sky, or in this case of the moon. And when I was doing my Messier certificate a number of years ago, I was kind of plinking away at it. But as I got more and more of them kind of weighed off, I was just kind of checking them off, and then I started to get a bit of momentum here. I'm thinking, wow, okay. And of course, with the Messiers, you've got this big cluster of galaxies in Coma Berenices and Virgo. And I've been through there a million times, and you see an eyepiece full of galaxies. And I did all these half-hearted attempts to sort which one was which, and the heck of it, I'll do it another time. That was the Virgo galaxies were my very last ones for the Messier, and I sat down one night. I said, okay, this is going to be it. I worked out. There's actually a strategy you can go online and find out. You come in from Denebola to do one. You come up from Beta-Mayatrix to do another one. And this is the way you attack them. I went out there, and in like 20 minutes, click, 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 I had the last 7 galaxies, and that was it.
Wonderful.
It was a good feeling. It was a really good feeling.
Yeah. And I really encourage the members to go onto the Canadian RASC site, rasc.ca, take a look at these programs, and go ahead, by all means, and start filling out your notes. It won't be long at all before you've got them filled out, and you end up with a nice certificate and now a pin as well. So just the other ones here, the Messier is 110 objects. The finest NGC is another 110 objects, recommended an 8-inch or larger scope for observing those. So, they're getting more serious as we get along. There is the Deep Sky Challenge program, which is 45 objects, but they're somewhat fainter, and they recommend a minimum 12-inch, and you may even need a 20-inch or better for some of the fainter objects, so a little more challenging yet. There is the David Levy's Deep Sky Gems, which I've only just become aware of, and I don't really know too much about it. There's a brief description here, and there's also the Isabel Williamson program for lunar observing. So by all means, jump right into these. So that leads us right into, I think Paul's here to present a certificate tonight. Page, please. Yes. For Stephen Godet. I'm not sure whether he's here tonight. Is Stephen here? No. Okay. Nevertheless, Stephen has completed the Explore the Universe certificate, the first of the series. That's the 55 out of 110 objects. Why is that not your name on it? It should be. All right. So going on from there, Chris. For the Finest NGC program, some pins have been created. We have a list of names. Let me see. I think if people are here, Paul will present them. We'll just see whether any of these people are attending tonight. So if you see your name there, are any of these people here tonight? I think I see one. Come on up. Yeah. That's Jeff, is it? Yeah. Congratulations, Jeff. There we go. Thank you. There we go. Fantastic. It was 6 years coming, huh? All right. Okay. I don't think any of the other people are here tonight. We'll make sure that these pins get to them. As you can see, they're fairly sparse. 97, 98, 2001, 2004, 2007. And we awarded one this year, if I remember correctly. Santosh Gupta, wasn't it?
That was an Observe the Universe.
Oh, I thought that was this one. Oh, no, that was, okay, that was the same as the certificate. That's right, okay. So the 5 here, and that's it. Okay, is there anything more to that, Chris? Okay, that's it there. Remind me, what are we doing next? Oh, yes, Chuck O'Dale and Eric Kuyala have a brief set of observations from the air. Thanks for coming. Okay.
Thank you and congratulations on that award. Chuck and I did an aerial fly over Algonquin Park last month, actually the day of the last meeting. Chuck and I have been exploring impact craters for the last 5 years using his airplane, my canoe, and various resources to document and learn more about impact craters right here on Earth. Most of the subjects we cover at the RASC are about up there, but there's a lot right here to discover. And so we did that exploration and filmed for about 4.5 hours from the aircraft. And our first objective was the Brent crater. If we go to that slide. The Brent crater is a very well-known crater in Algonquin Park. It was discovered in the 50s, actually, when a pilot was flying over. And it caught the attention of a lot of people, and they did some drill core sampling to find out what was actually there. And through the drilling, they found different layers of rock that are consistent with an impact crater. And Chuck and I actually explored this crater from the ground the first time in 2007. We went through by canoe. Where's the pointer? Here we go. Okay. So what we did is there's a road down here that gets to a point about here. We portaged the canoe, and then we came down to this point, which is a swamp. That's where that's our taking point to the crater. The crater is actually this whole thing here, and what's left are these 2 lakes. And they did some drilling in the middle, and found the evidence that it was an impact crater. So we did a canoe trip a couple of years ago, went down, there's a portage here, and then explored this lake here, and then back. I won't tell you where because we like to keep it a secret, but there's actually a piece of breccia in the lake, somewhere in the lake, that is not a not the best evidence that it's an impact crater, but it's the first time someone had actually seen breccia in that lake, and the only reason we found it was because the water levels were very low. Otherwise, it would be covered. So we looked at this from the air. We circled it for about half an hour, and then we headed south to, and I won't disclose the exact location, but to another crater that looks a lot like this one. If we could go to that.
Eric?
Yes, sir.
Go back. I just want to make a comment there, if you don't mind.
Okay, back to the other picture.
I'll just run up here and just do a quick one.
Sure.
Being an amateur geologist, Simon, are you here tonight? If you take a look at that crater, and it's all bedrock. Basically, it's all the Precambrian igneous rock that you see around here. But if you look in that circle, that's a plug underneath there of limestone. This whole area at one time was covered by that limestone with an ocean that was here. And the glaciers have scraped it all off except for the plug underneath that crater. And those two lakes are very acidic because of this limestone. So you just have to picture all this bedrock all over the place with this circular plug of limestone sitting right there. It's kind of cool.
Because of the limestone, the effects of acid rain are actually not as prominent in these lakes because of the amount of bicarbonate. So it's amazing how even after a very long time, how an impact crater can still have an effect. The crater is actually much older than most craters because it was actually buried in the Sea of Champlain for a long period of time. So it was protected from erosion. It's supposed to be about 450 million years old, and most craters only survive about half that time. So this is an interesting site. Now, the next crater that we went to, and I want to show you how remarkably similar they are. Look at that. Same idea. Obviously, there are some differences. This is not proven to be a crater yet, and this is why Chuck and I are interested in it, because in science, if you find something new today, it's a big thing. And for us to be able to prove that this is an impact crater is our goal. Now, if it turns out not to be, so what? We enjoy doing this. We love going out there, doing science, enjoying the outdoors, and so this is our next objective. And on Monday, we're doing a ground exploration of this area. We're going to actually try to find how to get into this supposed crater site. Obviously the lakes are similar to Brent, but what's really interesting is that in this area here, you don't see it on this side, there's an outcropping of there's some rocks there. It's a cliff face, and we're hoping to go there so that we can find shatter cones. Shatter cones are rocks that can only be formed from a nuclear explosion or an impact. And so for us, that'll be the objective. And the way to get in there will be to go into this little river here. And we don't know how big that is yet. And that's what we're going to find out on Monday. And then eventually we'll be able to bring the canoe in there and get our rock samples. I also want to take some water samples and things like that to find as many clues as possible about this site. And that's it for now. We'll keep you posted on what we do find. The last item I want to show you, I want to ask you, those who know what this is, raise your hands.
Title's on it.
Oh, you blew it. He did it again.
Guilty.
I couldn't resist. Nirvana, no one, I don't think anyone's ever seen it from the air before. So this is some photos we took on our way back, and I hope to actually go there to do some observing. I have a friend of mine here, Gordon, and I want to go there for that. So that's Nirvana from the air. Any questions? No? Okay. Thank you.
Okay, next up we have our observation reports for tonight. We've got 5 of them lined up. I guess we'll start off with Paul. I'll bring you the microphone if you like, Paul. Light off. The one over the podium?
Yeah.
Sure.
Testing 1, 2, 3. Hello.
Hello.
This is NGC 6853 M27, the Dumbbell Nebula. I recently took that, as you can see, and just to show you, as I said the other meeting, planetary nebula are very difficult to take because of the fact that they're sometimes very big, sometimes very small, they're odd shaped and all this kind of stuff. So this thing was, it's a 5-minute exposure stacked and that I took. And as you notice, there's a center star. That center star happens to be a 07 type of star. It's very hot, even now after the slowly the strata has come out of the planetary in the center. Okay, next please. This is a small little thing. You see, the other one's about 6 or 7 minutes. Now this one is only 61 seconds, 1 minute across. This is the other one was in Vulpacula. This one is in Cygnus, and this is 7048. And the center star in this one is 19th magnitude. I think if you look hard enough, you can see that. This is a 10-minute exposure. So it just shows you how these planetaries, how they vary from each other. They're not all the same. They're much more difficult to photograph than, say, galaxies or stars or open clusters or something like that. Next, please. That's the old Stephan's quintet. This is also an ARP 3, I think 319, and this is Hickson 92. These are interacting galaxies, as you can see. This is a 20-minute exposure, but the one on the left, the NGC 7320, does not be. It's much closer in. They're checking up to see if these things are although they look like they're all together, some of this is just line of sight type of thing. But the ones in the ones below the middle there, the 7317, they are interacting. So this is a very interesting object to take. It's in Pegasus, and you should, at this time of the year, you should be able to see that. They're all around the 13th magnitude. So if you have an 8 or a 10-inch telescope, no problem. Thanks very much.
Thank you, Paul. Next up, Gary Boyle.
Yes, back during the Perseid meteor shower, I was lucky enough to use Rolf and Linda Meyer's Excellent Skies. Who was out for the Perseid meteor shower that night? Just a fantastic night, cool, a lot of meteors, a great show. I hope everybody enjoyed. Well, here we have the small crescent moon, along with Venus, Mars, and Saturn, just about over here. So yeah, just the moon was very low that night, and it's amazing what you can do with just digital SLR cameras. Not hooked up to a telescope or anything, just simple wide angle on a tripod, just a few seconds. And I tried my hand at some astrophotography. This was 1 minute exposure tracked at 1600 ISO, Photoshop to bring out a little contrast. But just to show, next time I'll be doing more stacking of 1 minute exposures, just show you don't really need the 10 minute of tracking. So it was quite impressive on what came out. The Milky Way with Sagittarius over here, the Lagoon Nebula, the Trifid, some other nebula up here.
And you can see the dark horse in that image as well.
Yes.
Can you back up?
Yeah. Here's the dark horse over here. And we have M11, Altair. Just the Milky Way, just fantastic. And this is Almont over here. Okay, on the night of the 28th of August, I got Jupiter about 3:30 in the morning. Had some very good nights, 3 nights in a row. Here we have the shadow of Europa, and this is Io and Ganymede. And onto lunar, Posidonius. Whoop, oh no. Here I am showing everyone's, oh, that's it, folks. one thing about doing the moon or even imagery of planets like you'll see in Rolf, which you just saw with Rolf, is you can take a few minute video, but then you could spend hours in front of a monitor processing the images to try and get as much out as you can. And I did pretty good job on Posidonius. And the last one is Theophilus. I've actually practiced these names from last month. And again, a lot of good detail on the rims, a lot of good processing, but still, it's garbage in, garbage out. If you don't get good raw data, you're not going to get good imagery. So I was pretty happy with these shots. Thanks a lot, folks.
Thank you, Barry. Next up, Rolf Meyer with some insect observations.
See if we can see that. So this is fireflies, right? So that's pretty cool. So a lot of the time, it's gets a little frustrating because there's always, clouds and stuff in the sky. So, well, let's see what it looks like on the ground. But that's pretty amazing, eh, folks? There were a lot of fireflies this year, and this. What? Yeah, that's right. Yeah. So, yeah, that was pretty cool. Right. So, big problem we have here in Ottawa is the jet stream. You take a look at the path of the jet stream, and there's Ottawa there. The jet stream is almost always on top of Ottawa for some reason. And the problem with the jet stream is that's the interface typically between the Arctic air and the tropical air. So you got mixing of air, and that makes for a very bad seeing because of the temperature difference and difference of index of refraction. Now, normally it's very hard to see the jet stream because it's either in a high pressure system or there's a low pressure system. But on this particular occasion, on August 17th, you could actually trace the jet stream through the cloud patterns. So this was the observation from online. Which they get from measurements in the atmosphere, and this is the satellite picture taken at the same time. And then I thought, well, let me see if we go outside, what's it look like? So I took a picture. So here's Ottawa. So I took a picture to the south, and at the same time, and there it is. There's the jet stream. This band of clouds is probably in the middle of this band. So that's the problem we face in Ottawa, folks, is we almost always have the jet stream nearby, and very high altitude wind, several hundred miles an hour, and just messes things up. So there's Jupiter, and so that's why we never really get really good images of Jupiter. But anyway, these pictures were taken about a week apart, and it's interesting to see how the spots change. So there's the great red spot, and just barely visible there on that one at the edge. And just above the great red spot is another little red spot, and not too easy to see there. But then there's these other darker and lighter spots that seem to live on, like this dark one here is visible in both. This one here is extremely bright. This is probably the brightest feature on Jupiter right now. It's typically the same shape. And this darker spot is kind of a streak. And this sort of light area here changes shape a little bit. Most of the changes on Jupiter seem to be in the equatorial region where the winds blow the fastest, and as you get closer to the poles, there's a lot less change. Like this white spot here is about the same. Oh yeah, I should say the different belts move at different speeds, so you can see the relative difference in the position of this white spot and this dark spot versus here and here is the same spots. So I think that's it, eh?
Ralph, I have a question. Jupiter is on the outside of the asteroid belt. How come we never see any asteroids in front of the planet? Would they be too small, or because that asteroid belt we just saw in Al Scott's presentation looks like there's a lot of that stuff in there? Is Jupiter's orbit such that it's not actually between us and the asteroid belt?
That's a good question. I'm sure it's happened, you know, but they'd be very tiny. They'd be very tiny, and I don't think they would show up against
You've never seen
Jupiter.
one.
Well, they'd be very tiny.
I think they'd be so small and they'd be out of focus when you're trying to focus at that.
No, they'd be in focus, but they'd be just too tiny, too tiny. And Jupiter is too bright. You know, even if they were passing by, like the moons of Jupiter, except for the Galilean satellites, are probably captured asteroids, and they're really hard to see. So it probably happens all the time, but they're too small to show up like that. Maybe if something like Ceres or Vesta passed in front, one of the larger asteroids, but that's very unlikely. I never heard of that happening.
But is Jupiter exactly between us and the asteroid belt? Like, would the asteroids actually be in front of this image, even though we can't see them? That's what I'm wondering. Or is the inclination of the orbit such that Jupiter is actually above the asteroid belt from where we see it? That's
No,
what I'm
I think
wondering.
they.
Is there some kind of a connection there?
No, it's pretty much in line, I would
It's
say.
in line, eh?
Yeah.
Hmm.
Yeah, good question, but I think they're just too tiny.
Okay, thank you, Rolf. Start some really good conversation. So Ron St. Martin's up. Next, you may recall Ron amazed us with some film astrophotography that he'd done a couple of meetings ago. Well, he's back and he's got more.
Yeah, and you're not watching an episode of Doctor Who. I am using film. I am taking a little bit back in time, but this is one of the images I've got of the Perseids. I got one really nice one, if everybody could see it there. Somebody told me just aim the camera and take 10-minute exposures all night, so that's what I did. So I ended up with about 40 pictures just like this, minus the 1 meter. The next one, it's a nice shot at a double cluster. This is at 135 millimeter, a 5-minute exposure. Oh. The next one, this is kind of cool. This I found this. I got this one time taking a picture of Jupiter after twilight had started. So I waited about 40 minutes after twilight and took a picture at 100 or 210 millimeter. Got this wild effect.
That's all those little asteroids in a way scattering the light.
Yeah, that's the asteroid belt. There you go.
Rod, do you develop these yourself, or do you send them to a lab?
I sent them to a lab. I just use black, so you got their prepaid film. Cost me about $8 a roll.
And
So
that's
it's not very.
from a print, right?
Yeah, this is just scanned on my scanner, and then sent to Chris yesterday. Thank you, Chris. So I like to take pictures of weird and unusual things, and one of the things Tom Ray sent me up on was iridium flares. So one night I went out and I caught this one. It's a -6 magnitude iridium flare. It's right, and you can see Cygnus. There's a North American nebula. And you can see Cygnus here. And it's kind of cool that we got this big Cygnus star cloud in the background. So about 2 months ago, there was a -8 magnitude, and the background was amazing. This was a -8 magnitude iridium flare. And this was a 15-minute exposure using a 28 millimeter eyepiece or lens. And film at flow. You can see the telescope right here.
Ron, does the film have the same greenish tinge that the prints have? Or is that introduced in the prints? Because they all look kind of greenish, eh?
Yeah, well, again, it's film, so, and again, I'm not really sure about what I'm doing. I've only been doing this for not even a year yet. And when I started, I knew nothing about photography at all, so I'm just taking what I learned from people. And it actually, the print is actually a lot darker than that. It's not as green.
Okay.
So it looks a little better. It's just because of the scanned image, and that's raw, like that's right from the image.
What's that at the bottom there, that big bump?
That's the telescope.
Okay.
Part of the telescope. I tried to move the camera and get it out, but looking through the eyepiece, I think this was 4 o'clock in the morning. You know, your eyes kind of do tricks on you, and I thought it was all the way gone, but and this the fringe, that's just a little kind of a plastic thing that I put over the eyepiece so it doesn't dew up all the time or as much. I think that's it. Thank you very much.
Nice work, Jones. All right, let me see what we've got. Oh, yes. Next up, Brian, to address his own lunar challenge from last week.
All right, thank you. Well, yeah, this was a lunar challenge that just kind of popped up because Bob Olson had taken this great shot of the lunar surface here, and he was talking about this hook. Now, did he reckon, he was the one who said about the hook, right? Yeah, okay. So we thought, well, that's a good hook for a lunar challenge right there. So the challenge we created on the spot was, what interesting feature can you come up with? And you know, people see there's an X on the moon. There's the number 10, I think, and I found a number 8 by slightly defocusing my camera or my telescope and merging 2 nearby craters into an 8. I mean, I'll do anything to get a right. So I thought, well, I was out in on August. I forget the date, maybe I've got it marked. I probably have it marked. Sometime in August, and I was taking some shots of the moon, and I noticed something, and you will see as we go along. Let's go to the next one, please, Chris. Thank you. All right, so we have to backtrack first. Remember 2003? The happy little bonhomme in his stocking cap. That's the crater Maurolycus. And I had called, remember, I had called over to another member, a friend of mine, Lee McDonald, who has an observatory 1 block away, and I said, Lee, did you happen to take a photograph tonight? And he'd taken one within an hour of when I had sketched. So that's his whole image is huge, huge, huge. And I zoomed right in to grab this. So that's what I had sketched that night. So do you see the bonhomme there with his 2 eyes and it might be his pipe with the smoke coming out and his stocking cap?
Yeah, Bonhomme Carnaval.
Bonhomme Carnaval, yep. All right, so that was, okay, let's go to the next one. That was then. This is now, baby. Zagut, it's the screaming rabbi. Is it just me, or do we see the screaming face there? Oh, it's just me, okay. Now, but in this photo, there's something very interesting, because remember last month, I showed a series of images that I had taken of something. Sunrise at Sinus Iridum. Right, in the Bay of Rainbows. And I'd taken all these shots, digital shots through the eyepiece, and I was turned this way and turned that way, thinking, well, you know, we'll just do something with that, throw it all together. And Tim Cole helped me out. And what I didn't realize at the time, of course, was that every time I changed the angle of my camera through the eyepiece or switched around like that, it introduced different distortion effects. Now look at this. This is just in a couple of moments I took some close-up shots of this feature when I recognized this face feature with the 2 eyes and the mouth, and look, there's even a tear coming down here. But look at the different angle that those faces are facing. Do you notice that? Are they different? Yeah. A little bit? Mm-hmm. And that's just a function of having rocked the camera one way or the other. So I'm pretty convinced that I should put the camera away when I go to the observatory. All right, now this Zagut and Screaming Rabbi, this will make sense in just a minute. We'll go to the next one, please, Chris. That's the date I was trying to remember. July 30th, all right? So there's the area we were looking at. Now, the crater that Gary had shown just a few minutes ago, that nice close-up of the crater Theophilus with all that beautiful structure in the middle, is right there. So this is the north end of the moon up here. Here's Mare Imbrium. Right, there's the crater, the bright crater Aristarchus, the very dark feature Grimaldi, and what we're not seeing over here is because of the phase of the moon. This is where, this is Mare Tranquillitatis. This is where the Apollo 11 astronauts landed, right on the Terminator, right here. All right, there's the south pole of the moon, crater Tycho. Okay, so we're going to look at a strip like this, but I've shifted it around. Okay, let's go to the next one. So don't try wrapping your head around it. I flipped everything around and laid it out like this so that we can see things properly. So here's Gary's Theophilus, 100 kilometers in diameter. So there we go. It's half the distance between Ottawa and Montreal, from that rim to that rim. And remember what I like to say, there's the Tim Hortons right in the middle there, right there, okay? All right. And we walk down, and it's 3 craters in a row. It's, as we used to say on the radio in Toronto, it's 3 in a row on 1050 Chum Radio, okay? So the craters Theophilus, Cyrillus, and Caterina. Now, walking down along here, this is the Altai Scarp, or Rupes Altai, and it's marked there. It's 1,000 meters. So if you're walking along this part and decided to leap off here, you've got 1,000 meters to think about what you've just done. All right. So now we go along. Here's the and I've got the 3 craters that make up the face. Here it is right here. And as I was exploring along here, I thought, holy smokes, I've got something looking right back at me. So this is the crater Zygut. This is the crater Rabbi Levi, or Levi, and the crater Lindenau. Okay, now I'll show you something interesting.
There's another one there too, Cyrillus Catarina. Go over there. There's 2 eyes there and a nose and a face. There's the eyeball right there. You were supposed to.
Right in Catarina, you mean?
No, the 2 of them together. It's one eye on the left, one on the other.
Oh, Cyrillus,
there,
eyeball.
The mouth is right there, and the nose is just the bridge between the 2. Like an owl face.
Okay, so I think what the issue is here, that there are people in this room who need professional help. I'm at the top of the list. Oh, it's terrible because once you start on this, you go nuts looking for stuff. Okay, but now, okay, so here's the face that I had found that night. And remember, what did we start off with back in 2003? Our little Bonhomme? That's where Bonhomme is, right there. Let's go to the next one, please, Chris. All right, so there's our screaming face. There's Bonhomme, but you can see his stocking cap is on this side, and there's his body coming down. Here's his son d'eau is here, right there, and his head is up like that. So that's how close those 2 features are to one another. But, can you see on the other one? Oh, no, okay, now I remember how the rest of this goes. All right, isn't this great in a dark room? Let's go. This is just for effect. But not only was this the only one that I saw, but through my bad photography, I also found. Do you see it? Right eye, left eye. There's a little nose. There's the mouth. There's the chin. Tall forehead of a brainy person. That's the only type of people who come here. A potato head, yeah. Not bad for bad photography, but I mean.
Not bad at all. We've got one more observation tonight, wasn't on the list. Jonathan Kukan has also got just a verbal observation this time.
That's right. You want to take the mic? Okay.
Yep.
Yes, just a brief story about how visual astronomy often surprises you and catches you off unprepared. And I'm glad that Gary had a picture of the meteor maximum that was on August the 12th. You remember with the lousy weather, it canceled 2 of our star parties. But the meteor maximum was such a beautiful night that I called up the group that I'm with. In fact, I belong to a small non-denominational biblical astronomy group. I called them up and said, hey, let's go over to Penny's Point, where most of you know where it is, and just lie out there and count meteors. So I decided to go there a bit early. And being that I wasn't going to be doing any telescope work, I didn't bring my camera, I didn't bring my telescope, but I wanted to go early just so I could see the sunset. And because where I live, I can't see the horizon. So I went there, got there early, and to my surprise, within 1 hour before dark, I saw 5 solar system settings. First of all, the sun, and that was beautiful. Everyone knows that. Then the moon, and Gary had a picture of it. Then the moon set, and that's always beautiful visually, and especially in binoculars. But then along comes Venus. And it surprised me because it went, again in a short time, it went from the bright blue-white color, and as it got toward the horizon, it turned bright yellow. And then as it hit the horizon, it was a bright yellow-orange. So it really shocked me on that one. Right after that, Saturn set. And it too changed color, but it wasn't as dramatic. But then the most interesting one was Mars, the last one that set. And by the way, this is still daylight. And Mars comes, and again, we know the color of Mars. It has that faint orangey, reddish color. But as Mars approached the horizon, And through the binoculars, because I didn't have my camera and I didn't have my telescope, but through the binoculars, it started flashing a bright, deep blood red. It was really shocking. In fact, you know, you look at that, and right away, you get a sense of history. And, you know, for all of you who are amateur astronomers like myself, you know, you should study history. History will add a lot to your astronomy. Now, taking a look at that freakish sight of Mars turning bright blood red, you understand why the ancients associated that planet with war and bloodshed. Of course, we now know what atmospheric conditions do. But it was really freakish seeing this. And then, of course, later on, the skies got dark, the group came in. We did a scientific calculation of the number of meteors. We got the 2 kids in the group to do the count. And just before midnight, they had counted 35 meteors. And then Mom and Dad comes along, spoils everything, and says, you're way past your bedtime. So they had to go home. I stayed a little while longer till it was past my bedtime, but it was a very pleasant evening. But just a little warning to you, next time you go out, don't go unprepared. You never know what the skies will throw at you.
Okay, now if Paul is here, he's going to do all of the challenges this evening. Thank you very much, Paul.
All right, more than welcome. Well, good evening, astronomy fans. I just wanted to take this opportunity to pose a few challenges with the cooler and longer nights approaching. This is certainly my favorite season of the year to do observing, and hopefully we'll get some clear skies to take advantage of those longer and cooler nights and bug-free nights. So I've got 3 challenges for you tonight, and actually if we could dim the lights there a bit, Gary, thank you. My first one's a lunar challenge, and sort of going on the theme with the shadows. This is really a follow-up to a challenge that, or an observation that I showed back in January. Some of you may remember the odd shadows that I saw in the floor of a crater called Hommel C. If I could get the first slide, Chris, please. There we go. You can see that's the crater there. These shadows just struck me as kind of peculiar in shape because I've done a lot of lunar observing. I've never really seen shadows from the rim of a crater in quite that form. They're usually kind of peak-like, but these look blockish and more like mesas and buttes. So this caught my attention, and I wanted to try to figure out what it was we were looking at here. Next slide, please. So just to give you a sense of scale, this crater, Hommel C, is in the southern lunar highlands. It's not a huge crater by lunar standards. I've superimposed a map of Ottawa just to give you a sense of scale, and you can see it's about 50 kilometers across, and the Ottawa region would fit nicely into this big pit. The next slide, please. So as I said, these shadows struck me because of the odd geometry. I was wondering what could project these shadows into the floor like this. And as you'll notice, there looks to be an overhang on this crater. Now, sorry for the fact that it's not all that clear. This was not a great night when I shot this back last year, but I had to take the picture just because it struck me as an odd thing. But it was clear enough to determine that there's an overhang or some sort of a structure sitting on the rim of that crater, and I thought that's probably what's causing those. Certainly the angles, the illumination and the shadow angles seem to jive, but they just struck me as kind of odd because they seem to be projecting out so very far. So either there are a couple of mounds sitting on top of this overhang, or maybe the overhang was just jutting out a lot farther than it appeared to be from these images. So what I tried to do, what I decided to do is just observe this crater, try to observe it under slightly different phase conditions to see if I could determine what the source of these shadows are. As it turns out, that kind of a project's a little bit like winning a lottery, because to try to get the moon at the same phase angle over the months is you have a very narrow window of observation, probably only about 10 hours long, and that block of 10 hours can occur when the moon's on the other side of the planet, or when it's low in the atmosphere and it's very murky for high resolution, or heaven forbid, when it's cloudy. That happens here, as Rolf was indicating. So it took me the better part of a year, but 2 weeks ago I was successful in imaging this with a slightly different angle and actually determining what this was. Next one, please. So what I tried to do initially was have a look at some other resources, try to see what I could see in terms of a structure to see what was causing this. The lunar lac chart for the area seemed to indicate that there might be a couple of objects up there that could be the cause, maybe. A high-resolution image from the lunar orbiter didn't really shed a lot of light on the subject there. There wasn't really anything that sort of leapt out at me to say, these are the sources of these shadows. And unfortunately, with that image, the angle of illumination when that was taken by the spacecraft was opposite what I was viewing there, so the shadows are actually flipped on the opposite side of the crater. Oh, that's life. Anyway, next one, please. So 2 weeks ago, I was successful. Again, it wasn't one of the clearest nights, but it was okay. It was certainly clear enough so that I could bag these two images on 2 concurrent nights. This was August 28th, and you can see I picked up the shadows there. Again, just to show you how narrow this observation window is, this was 22 hours later, and you can see the floor of that crater is now almost completely hidden in the shadows. So you don't get a lot of time to try to bag this. Next, please. So if you enlarge that view, you can see there's the shadows, but they do look different. This was slightly earlier than my original photograph, and you can see that the shadows are actually not connected to the rim at all. In fact, you can see this one is completely isolated, and this one has a bit of a connection to it. But as it turns out, these shadows weren't being cast by anything on the rim at all. They were being cast by something on the floor. So it was an illusion. And as Brian mentioned, there's a lot of those happening on the moon.
On your left chart, if you go back.
Sure. Yep.
You can see the objects, right?
Yeah, you can see them. But
There, and that's what I was thinking. Maybe that's what the cause of it is. Then.
yeah, but see, I was biased. That was my own observational bias. When I first saw them, I thought, well, those are really weird rim shadows, rim mountains casting those, and I sort of went on that assumption that that's what they were and tried to find them. And it's a lesson from science. You shouldn't bias your own observations like that by drawing premature conclusions. But anyway, this image does show that in fact, yes, you're right. They were caused by something on the floor. If we zoom in a little bit more. Again, it wasn't the steadiest of nights, but close enough to get in. You can see that this shadow is completely disconnected. This one has a bit of a connection, and you can see where the illusion comes in. In fact, my lady looked at this originally, and you're talking about objects. Well, you know what? Guess what she saw with this one initially?
A woman with a hand on her hip.
No, she saw a dead rat. Can you see the dead rat? She says, it looks like a dead rat.
You see the woman with the hand on her hip?
Yes, I do, actually, yeah, right there. Yeah. What do you think, woman or dead rat? Can I have a show of hands for dead rat? All right. So, and again, as you can see, only 7 hours of time actually separated these different phase angles on the moon there. So the 7 hours makes a difference between that revealing itself as to what it is and the illusion that I saw initially a year ago. So next one, please. When I saw this shot that I took 2 weeks ago, I went back to the lunar lac chart, and it occurred to me, wow, you know, this is a grayscale image. If I reverse the pixels, maybe I can get the lunar orbiter image to mimic my shadows, and by reversing them, you kind of flip the shadows around. And sure enough, when I did that, it was very obvious as to what the source of these objects were. They weren't on the rim at all, but they were these two hills at the floor of the crater. So, next one, please. So, interesting. I mention this now because. As I say, the opportunities to see this particular illusion on the moon are rather fleeting, but in about at the end of this month, on September the 27th, is probably the best opportunity of the year to try to see this for yourself and see if you get the same impression. It occurs just after midnight on Monday, the September the 27th, and the moon will be nice and high, about an elevation of 45 degrees. So it's relatively easy to find if you go to the next one. The area of interest is down in this part of the moon. You can certainly find crater Tycho fairly easily. If you can't find that, you shouldn't be observing anyway. But find crater Tycho, head east towards the terminator, and then a little bit south to this area of interest. Next slide, please. Once you do that, you should be able to pick up the crater Janssen. This was excuse me, a large ancient walled plain, heavily fractured. You can see this whole surface is very mottled with features, but heavily fractured here. A lot of rills running through there, and a very dramatic cleft. So if you can find this, then you just head south a little bit along the Terminator to the Hommel group, and those shadows should peek out at you very readily. And as I say, if you do it at 12:30, it'll be like my original observations. The shadows will actually be much more prominent than that, and you'll see either the woman or the dead rat, depending on your preference. So, next one, please. So, the next challenge I have for you is Jupiter, and as Rolf pointed out, this is a good time to see it. This is actually an excellent time to see Jupiter, and I highly encourage this. This image itself was actually. Can I get the next one there, please? Oh no, can you go back one? Sorry. This image was taken just at the end of the month by Anthony Wesley in Australia, and it's been called one of the finest images ever taken of Jupiter by an amateur astronomer. And I don't find that hard to believe, because look at the detail here. It's just exquisite. This looks to me more like a Voyager shot. You can see the festoons in the atmosphere. You can see, look at the details on the spots here. And of course you can see the red spot. At this point in time, this is a great time to see Jupiter, because we're only about 10 days away from opposition, which means Jupiter's closest approach to us here on Earth. And this opposition is particularly wonderful because it's occurring with Jupiter very close to the perihelion point in its orbit, and with us on Earth very close to the aphelion point in our orbit. So we're about as close as we get. And that means that Jupiter is about as big as it gets from our point of view here on Earth. In fact, it hasn't been this big in the last 60 years. So this is definitely the time to go out and see it, because it doesn't get much better than that. On top of that, sorry?
Yeah, as big as a full moon?
As big as a full moon, yeah, big as a full moon. It's 50 across, 50 units, whatever those are. Now, if you want to talk about jealousy of places to observe and things like that, Anthony was observing with a 14.5-inch telescope in Australia, and apparently what had happened that night was that a very stable, very transparent air mass settled over the western part of Australia for about 4 hours. And at his latitude, Jupiter is about 70 degrees in elevation. So it's not far off the zenith. It doesn't get much better than that. He was in the right place at the right time with the right equipment. So hats off to him for just a stunning image there. But even for us here, although the conditions aren't going to be nearly as good as that, they're still not bad. This opposition is definitely worth checking out, and so the challenge is to see the red spot. If you've never seen it before, you're never going to get a better opportunity. And for the keeners in the crowd, the uber challenge is to see the little red spot down below. Its little brother down here. The little red spot is about a third or a quarter the size of the red spot itself. Currently, it's hanging in underneath the red spot, and it should be fairly easy to pick up if you've got a stable night, because you've got this dark feature in the atmosphere which virtually points right to it, right under the great red spot. So you want to know when the great red spot is going to be transiting, or basically front and center on the surface of Jupiter. If you don't have a program or a utility that does that for you, just go up on the Sky and Telescope website. They have a nice little online calculator there that will tell you exactly when the red spot transits. And that's when you want to try to see it. It's just an awesome opportunity. Next slide, please. I took this image myself a few weeks ago, and even this was only with a 6-inch telescope, and even with that 6-inch telescope, you can see that I managed to bag the little guy down below the great red spot. And of course, I picked up a few of the moons. This is Io and Ganymede and Europa out here. So even a relatively small telescope will show, on a clear night, will show you a wealth of detail in Jupiter, especially with its size at this point in time. And so I encourage you, and you've got to keep your eyes open, because you never really know what else you might see while you're observing this. Next one, please. So I took this image on August the 20th, image of Jupiter. I was trying to catch the transit. One Jupiter rotation later, 10 hours later, this gentleman in Japan was also going for the red spot. You can see the image at about the same scale as I was, and he got the red spot. It was pretty much the same orientation, but he also got this guy. Watch that flash. Watch that flash. Can you see that? what he managed to pick up was a small asteroid or comet slamming into the upper atmosphere of Jupiter. Pretty impressive, eh? And I just read today, there was a report published in one of the astrophysical journals that a group of scientists have been analyzing this because we've seen a few of these events in the last little while. And they're saying that this is actually, we're starting to believe now that this occurs much more frequently than we previously thought. This is in fact the third impact that we've seen on Jupiter in just about the last, I think, about 13 months or so. So it's pretty cool, and this was actually imaged by 2 amateur astronomers concurrently, so they verified each other's discovery, and this is a genuine impact in the atmosphere of Jupiter. So as I say, this occurred about just one full rotation of Jupiter after I took my shot there. Missed it by that much and half a world away. Oh well, say la vie. All right, next one. The last one I've got for you is a deep sky challenge. Now, and I'm really glad Paul Commission showed us that image of M27 because he just confirmed something I've been thinking about. The Goldilocks variable is a really cool variable star if you've never heard of it. Next one, please. It lives in M27. It's a variable star in M27. Now, these 2 images I took last year, one in August, one in September. I was comparing 2 different cameras, same telescope, same object, but I was comparing my Canon Rebel on this side with an Orion CCD imager, a much more sensitive camera for astronomical work. And I wanted to see the difference. I wanted to see the amount of difference in terms of the penetration, the faint nebulosity, and so forth. And as you can see, the CCD imager picks up a lot more of the faint nebulosity. Next one, please. So I went back and I thought the challenge that we have going here is the Goldilocks Nebula. And I looked at my images here, and you can see the Goldilocks Nebula right in the center of these 2 circles here. If we zoom in on this, this is where it gets interesting. You can see this is the image from the Rebel, and this is from the CCD camera. And you can see the more sensitive camera, well, the Rebel actually recorded that star more brightly, 25 days apart. As it turns out, this variable star, called the Goldilocks Nebula, was discovered by a Czechoslovakian amateur astronomer only about 20 years ago. And he discovered it in an unusual way. He was looking at the cover of, I think one of the magazines was Astronomy, and a few months later he was looking at another magazine called Deep Sky. They had both published pictures of M27 on the cover, and he noticed that on one cover the star was there, on the other cover it wasn't. That's how he discovered it, and he's been credited with that discovery. So talk about armchair astronomy, right? So, but that's only 20 years ago. And so these 2 images I took last year. Next slide, please. This image was taken by Dave Jurasevich. I'm not sure when he took this, but it looks like he took this at a time when this variable star, this mirror variable, was close to its peak in brightness, because when it is, it's almost as bright as the central star in the Dumbbell Nebula. And Paul, I saw this on your image. You just took this about 3 weeks ago, I think, right? Yeah, about 3 weeks ago. So my 2 images, I estimated, there's not a lot of data actually published on this variable, but what I did have, I estimated that the 2 images that I shot were taken at around this time, or this position on the light curve, and so you can see that from one image to the next, it dropped by about a full magnitude, and that's pretty much what you saw on my images there. Mr. Jurasevich's image shows it at a much brighter position. And I was going to say with my talk here, I haven't got firm numbers on this, but I did a rough calculation, and I'm thinking that this variable right now is close to its maximum in brightness. And your image confirmed that for me, because I could clearly see that in yours, and maybe we can go back there afterwards and have a quick peek at that. But, so I encourage you to go and try to see this, because it's in, actually, if we can flip back, just flip back 2 images, please.
Hold on a second, because I'm doing something for you.
Are you? Oh, he's getting fancy. Are you correcting dates again, or what?
No.
No? Oh, there we go. Okay, so there it is right there. Right there, and look how bright it is. It's certainly brighter than on my 2 images. It's not quite as bright as the central star, but I was thinking that this variable was close to its brightness, the top range of its brightness right now, and so you should be able to pick this up with about a 10-inch telescope. And because it's in this nebula, this is you've got a lot of reference stars. You've got the central star. You've got this sort of straight line of stars, a fairly bright star off to the edge. You can use these to try to bullseye this little formation, and you should have no problem with it. 10-inch. I have seen this visually in my 10-inch telescope. Other times when I've looked at it, I'm assuming that it was at the lower part of its scale. This variable star has a period of about 7 months, and in that 7 months, it changes brightness by 4 magnitudes, which is quite a big range. So it's a mirror variable, a giant red star that is actually believed to be, the whole thing is pulsating. It's expanding and contracting, and that's what causes its dramatic shift in magnitude. So this is the best time of the year to observe the Dumbbell Nebula, and it will be for the next couple of months. So I encourage you, if you have I think you pretty well need a 10-inch telescope when it's near the peak of its brightness to see this visually. Of course, if you're doing any imaging, a smaller telescope will capture this quite easily. So see if you can get out and see that. It is a cool star to see, and the visual impression I got when, as I say, I've seen it with my 10-inch visually, and it's quite reddish in color. And then other times when I've looked for it and it's gone below the visual threshold of my 10-inch, it's like the stars just disappeared. It's not there anymore. So it's kind of a cool effect. So the last one I have for you is just a shameless commercial promo. For any of you that are interested in astrophotography, have thought about getting into it or are into it and maybe want to learn a bit more, I'm going to be doing a 2-day workshop at the School of Photographic Arts at the end of October and in the first week in November. This is 2 sessions that we're running there, plus a field session that we'll do under a dark sky site. It's basically targeted for beginners or intermediate level astrophotographers that want to learn a bit more. So if you're at all interested in this, the website is www.spao.ca, or we've got that phone number there. You can register there, it is I think it'll be a pretty interesting workshop there because we'll run through the gamut of things. We'll talk about the theory, the techniques required, the equipment that's currently used, and we'll spend a good portion of time on image processing, which for anybody that's done this stuff knows is the bulk of the work actually to tease out the details there. So we'll be looking at programs like Photoshop and Registax to use in processing your astro images. So if you want to check that out, feel free to call that number or check out their website and feel free to register. So that's all I got. I wish you all clear skies, and I'd be interested to hear about your observations on any of these challenges.
Hey, Paul, your date for the lunar challenge, the Humble C, you said it was the 27th, Monday the 27th?
Yes. Just after midnight. Yeah, the exact time is 12.
Morning or Monday morning?
That's Monday morning. Monday morning, yeah.
Is the 27th then?
Yes. Should be yeah, I think did I get that right, or are you going to change the date? Or did he change the date on me while I wasn't watching, or what? No, it is the Monday morning. It is the Monday morning at 12:33 is when that phase angle will be exactly at that position. Okay, any other questions about any of that? No? Well, good luck with your observing. Thank you.
Thank you.
Okay, we're starting another what I hope to be a regular segment for the meetings going forward. Just a brief mention of an item out of the Stan Mott Book Library from our librarian, Estelle Rother. In this case, I'm kicking it off. I was recently browsing around NASA sites, and I saw that they were sponsoring an offer. You could, if you were a U.S. citizen, you could send an email to them, and they would send you a copy on DVD of a NASA-sponsored presentation, Journey to the Stars, being presented at the American Museum of Natural History right now in New York. Anyway, I'm not an American citizen, but I thought, I'll send him an email anyway. I mentioned that I was meeting chair for the society, and I thought the members might enjoy taking a look at this. And sure enough, a couple of weeks later, DVD arrived in the mail. So I watched it. It's not deeply scientific, I wouldn't say. It's narrated by Whoopi Goldberg, so what would you expect? But nevertheless, it's quite entertaining. There's some pretty good video in it overall. a lot of CG stuff. There's some interesting material on the gravitational field, the black hole at the center of the Milky Way galaxy, for example. Some animation there that I rather enjoyed. Anyway, I've dropped it off with Estelle. It's available in the library. Feel free to take it out and I guess try and take care of it. There's only one of them. But other than that, in future, I think Estelle will be making a suggestion each month of a book out of the library that might be of interest, and we'll just say a few words about it to make you a bit more aware of what's available. Next, please. Okay. Other than that, so we're into the kind of end of meeting announcements here. We've been contacted by a fellow, Sean, I don't remember the last name right now.
Sean White, I believe.
Okay. Anyway, gentleman is a member of the center. Sean Clark. He's a member of the center, and he's starting up a business around high definition portable digital planetarium. It's basically, it looks like an igloo. You can see it here, but it's a portable planetarium. Can be set up wherever it's convenient, and then present inside of it. So I think he's trying to make a go of it.